Alright, welcome to your video lesson for section 2.2, and this is about the quadratic formula. In the intro part of this, you're basically seeing how the quadratic formula is derived, and you don't have to memorize all the steps of this or anything like that, but it's always interesting to get a little bit of background knowledge as to where formulas come from, just a little depth of knowledge on this. But basically, if you were to go through the completing the square process, and take the basic outline of a quadratic that you see right here, if you were to complete the square like you did in the previous lesson, and you can go through all the steps of that if you'd like to see them, but it does lead you to this quadratic formula. And this is a formula that you do need to memorize. You're not given this formula, so you do need to be familiar with it. But you know, as far as a, b, and c are concerned, a is always that value in front of x squared, b is always the value in front of x to the first, and c is always your constant. And before you determine all those values, you always want to make sure that the entire thing is equal to 0 before moving forward. So just to go through a couple examples with you. So using this with the quadratic formula, just as a side note, keep in mind that this is most often used when other methods aren't available. So for example, when you are solving a quadratic, we really like to solve by factoring, but some quadratic equations are not factorable, so you need other methods like completing the square or using the quadratic formula to get answers like this one that you could not get by factoring. So just taking the values, if a is 3, b is 4, and c is -1. So if we just sub those into the quadratic formula that you see here, it's going to lead us to this setup. One thing I encourage you to do is, as people start going through this and they get more and more comfortable with using it, they tend to skip steps and try to go as deep as they can without showing work. So just be careful on that. It's always good to write the complete setup before you move forward and begin to simplify. Watch out for little things like this. You have a double negative right here. So you got a negative there and a negative there. So we're really looking at 16 plus 12, which is leading us to that 28 that you see right there. So that's usually the best place to start, is to simplify your radical. Once you get to that stage, if you simplify the square root of 28, you're going to get this look here. And if you can reduce, you're always supposed to simplify numbers like this. So if you notice, all three of these are divisible by 2. So I'm dividing all of those by 2 to get this finished look that you see here. Keep in mind, you cannot reduce an item from here with only one item up top. Whatever you reduce by must go into all three terms in order for you to simplify. So don't just try to do part of it without doing all three terms at the same time. Just another example right here in part B. This is one of those cases where it's just a good idea to pause if you want, give one a try on your own. So if you take the value for a being 4, b is 5, c is -6, and again plug those into our quadratic formula. This would be the setup. And again, on this one you do have another double negative, so you got the negative right there, you got the negative right there, so I'm going to be doing 25 plus whatever 16 times 6 is. And so that's what leads us to that number right there, which we call the discriminant. And we're going to get more into that into the next section on what that discriminant tells you. But in most cases, you get a positive discriminant. So because of the plus or minus, you do get two solutions in most cases. That's the norm, is to get two solutions or two rational roots because of the plus or minus when the discriminant is positive. But we know that the square root of 121 is 11. So that gives you this look right here. Don't forget, order of operations on this is you have to divide last. So you're going to do -5 plus 11 and get that answer, then divide by 8. You're also going to do -5 minus 11, then divide that answer by 8, and they do need to go in that order to get those two solutions. Moving on to just a couple more examples here. These are going to be pretty brief notes, but here's just another look where, again, if you just take a as 9, b is -12, and c is 4, and go through the same quadratic formula process here. If you plug those in, so notice this is one of our special cases right here, where you're going to end up with 144 minus 144. So your discriminant is 0. And if your discriminant is 0, that means you're only going to get one solution. Because if I do 12 plus the square root of 0 divided by 18, that's the same answer as doing 12 minus the square root of 0 divided by 18. So I'm getting the same solution twice. So there's really only one solution to this. You can look at it as one solution that repeats itself, or you can say there are two real roots, even though those two roots are the same value. So we tend to look at this as one solution when the discriminant is 0. Here's your other special case. If you were to take this and sub those numbers into your quadratic formula, notice on this one, you get a negative discriminant. So obviously we can't take the square root of a negative value, which means this problem cannot go any farther, so there are no real roots to this one. So those are your two special cases. Your normal cases are where you get two different solutions, but these are the two special cases. And we'll get more into the discriminant for the next section. For these last two, last three, these are just cases where you got to do a little side work before doing the quadratic formula. So you got to get to the standard look that you see here, where everything is on one side so that the entire thing equals 0 before you start plugging numbers into the quadratic formula. It's usually best if your a term is positive, so I would always encourage you to put everything onto the side of the equation that would make your a term positive. So in this case, here's my a term, it's already positive, so I'm going to get everything onto the right side of the equation. So I'm going to subtract 3x over to here, I'm going to add 2 over to there, and that's going to give me this look, and now this problem is ready for the quadratic formula. As you simplify, again, here's another case where you can reduce your answer, so make sure that you do that. 2 can divide into that term, and that term. So if I divide all three terms by 2, then that gives me this look here. One word of caution on that, because this happens all the time. If I divide this by 2, it doesn't go away. A lot of times people see this as canceling out the 2, but it's not canceling out, it's dividing it out. So you're still left with something there. So you still need a value in that place. So don't forget that. Don't leave it as just the plus or minus rad 26 over 5. That would be wrong. You got to have the value in front still. Again, here's just another case where it takes a little side work before using the quadratic formula. In this case, I would multiply all three terms by x in order to get this look here. Then I would subtract 10x over to the left, and now it's ready for the quadratic formula. That's supposed to be a 0. I know it looks a little bit like a 6, but that's supposed to be a 0. And again, another case, all those are divisible by 2. So divide everything by 2. That's going to give you that look here. And then here's just one last case. Best approach on something like this would be to cross multiply. So if I did x times x plus 4, that goes on one side of the equation. On the other side, I'm doing 3x plus 2 times x minus 1. So if you FOIL that out or distribute, you're going to get the look that you see here on the left side of the equation. And again, before you go to that quadratic formula, get everything onto one side, make it equal 0. I would put everything onto the left side for this equation so that my a value is positive. Then you're going to go ahead and sub into the quadratic formula. And that's it.